Let's use StatKey to take some data and estimate the mean for a population based on a sample and find a confidence interval. So here we're asked to find a 95% confidence interval for this temperature data. So here's our sample data. I'm just going to copy that. In StatKey, we want to do a confidence interval for a single mean. And here, they started with their Mustang price data. They have many others. We're just going to edit this data set by highlighting all of it, deleting it, and pasting in our data set. Now at this point, it does not have a header row. Okay. So here's a box plot, or sorry, a dot plot for our sample, and we're going to use that to generate other samples. Now remember, each one of these points here is the mean of another sample. And so here is the resampled version of the original data. And so over and over again, we shuffle the cards and draw some cards out. Each time we're drawing 11 cards here, and we get a new sample. We take the mean, and then we plot the mean. So this is what's known as a sampling distribution of means of samples. It's a good idea to generate at least 5,000 of these samples based on the original. I have 4, 5, let's go with 6,000. And there's a whole bunch of dots here, and every dot is a different sample over here on the side. Okay, and this is our original. So again, I have my sampling distribution. I have a reasonable number of resampled pieces of data. And so I'm going to go for 2 tails here, putting 95% in the middle. Now we were asked to do a 99% confidence interval, so I want to rewrite that as 0.99 for 99%. That puts 1% for the tails to share, so each tail gets 0.5%. Along the bottom here, I get 2 pieces of information. The sampling distribution has a mean of 52.714, which is close to the mean of my original sample. And then I have these estimates on each side. So I have 5,000 samples. Each of those samples has a mean. Just less than 1% of the samples are living on this tail. The other 1%, or 0.5%, lives out in this tail, leaving 99 in the middle. So 99% of the samples that I generated have means, right, averages, that are between 46.45 and 58.641. And so what we can say is that we're 99% confident that the mean temperature for this particular population is somewhere between 46.45 and 58.61. So we next need to split the screen, pop that into the system here. I want to enter that as an interval. So a confidence interval is often entered with parentheses. Lower number, around to 2 decimal places. The original data had 1 decimal place. Usually we do an extra decimal place when we do calculations based on data. And the other one is 58.64. That's our confidence interval. We think the population has a mean of about 52.71, and that the actual population mean is somewhere in between 46.45 and 58.64, or 99% confident of that. So submit that, and we get a green light. And you can see the answer now. So the answer that's calculated might not be exactly what StatKey predicts, because this is based on simulations, but it's going to be within a couple of percentage points of the predicted answer based on the central limit theorem, which we'll get to later in the course. So we're not going to worry about that yet, but StatKey gives us a great tool for simulating a whole bunch of different samples where we only have maybe the ability to take 1 or 2 samples. We can reshuffle that data and get thousands of other samples that help us predict the population. So that is my confidence interval for a mean of temperatures. Thanks. Bye-bye.